In this problem, we're given several radical functions and asked to find the domain written in interval notation and also to find the horizontal and vertical intercepts. I just finished a video where I answered the first function and thought that we should probably do one that is a little more complicated. So I chose to do the bottom one here, p of x equals the sixth root. And because my index is 6, which is an even number, we're going to have a restricted domain because you cannot take the even root of a negative number, and there's certainly some x values that makes you a radicand. The radicand is all of this. Whatever's underneath the radical is called your radicand, and if that thing comes out to be negative, we're going to have issues. The sixth root of a negative number is the result is what's called a complex number, and that's exactly what we're trying to avoid by restricting the domain. So what I'm going to do is I'm just going to find the domain in this one by writing down what would come out nice. So the x values that would make our outputs real would be is if your radicand here, negative 3 minus 7x was bigger than or equal to 0. It could be 0. If that thing came out to be 0, you'd have the sixth root of 0, which is a real number. Things work out nice. Everybody's happy. So we will allow that x value that does that to be part of the domain. So I simply need to solve this inequality first by adding the 3 over, say. And if you did that over here, negative 3 plus 3 is 0, so I'm not going to write it. I'd have negative 7x is greater than or equal to 0 plus 3 is 3. Since the negative 7 is being multiplied, the correct way to solve is to do the inverse, which is to divide by negative 7. Now this is where you have to be careful. If you remember the rules, and I could do a separate video showing you why the rules work, but whenever you divide or multiply by a negative number with an inequality, a less than or a greater than, you need to switch the symbol around. I just did that. I divided by a negative. So if I were to divide by positive 7, you would not do this. But negative 7 divided by negative 7 is 1, so no one writes the 1. We just write x instead of 1 times x. I need to change that to less than or equal if I want this to be an equivalent statement to this one. So x is going to be less than or equal to negative 3/7. And if I have time, I'll graph the function to show you that this shows that on the graph, that however it plays out, the points are all going to have the condition that your x values are smaller than or equal to negative 3/7. In fact, x equals negative 3/7 is the value of x that actually makes that radicand 0. And the sixth root of 0 is 0. So that actually turns out to be nothing less than my horizontal intercept. So I'm going to jump to the horizontal intercept since I just really did it. To find a horizontal intercept, the idea is if you're on the horizontal axis, one thing you know about that point is that the output 0. So the technique of finding the horizontal intercept is to replace your output, p of x, with 0. And you would do that. I actually just did that, except I also had the greater than symbol. But that little equality symbol there took care of this equation that I'm about to write down, sixth root of negative 3 minus 7x. To solve that, I need to do the inverse of the sixth root. The inverse of a sixth root is to raise to the sixth power. So I'm going to raise 0 to the sixth power. I'm going to raise all that to the sixth power. And 0 multiplied by itself 6 times is 0. The sixth root and the sixth power, those two functions cancel because they're inverses, so you'd be left with negative 3x, negative 3, and then minus 7x. If I add the 3 over, it would look like this. 0 plus 3 is 3. Adding 3 on the right-hand side cancels that out. Negative 3 plus 3 is 0, so you don't need to write plus 0. The negative 7 is being multiplied, so you divide it over much like we did before. So if I divided the left by negative 7, the right by negative 7, this simplifies down to be the number 1. But instead of writing 1 times x, we just write x. So that was just a fast way of showing you that x equals negative 3/7 is indeed the input right here that gives you an output of 0. So this is going to be the point. Negative 3/7, didn't give myself enough room to write it in there, comma 0. And then what's going to happen is my domain is such that the graph has it so that all the x values of the points are smaller than that, which means when I graph this, the graph is going to do something like that. So just to show you how to do this on the graphing calculator in case you wanted to check it, if you go to your graphing calculator, turn it on, hit y equals. To get the sixth root, you press the 6 first, and then you go to math, and then you select option 5. I don't like the way this notation looks. If my calculator was in math print, what would actually happen is the 6 would not even be written here, and there would be no x. The x is being replaced with 6. So this looks like 6 times the x root, but it really is the 6th root of, and I need to type in the 6th root of negative 3, and then the subtract key, and then 7x, right? Oh, you know, it didn't give me a left parenthesis. That's dangerous. So I'm going to back up here, and hopefully I did it ahead of you so you don't have to do this, but I'm going to insert, which is second delete, a left parenthesis there. I thought that I was going to get one for free when I did the 6th root, but I didn't. So make sure that your negative 3 minus 7x is in parentheses, otherwise you will not be getting the graph you want. So there's my function, and I'm going to want to graph this in a standard window. So to do that, I'm going to hit zoom 6 for standard. That sets my window from negative 10 to 10 on the x-axis, negative 10 to 10 on the y-axis, and graphs it for me. So notice the graph has that shape. The thing that the calculator doesn't give you is where exactly does it hit the x-axis? You know, that's hard to see, but we found that it was negative 3/7. In fact, if I was to hit trace to get some coordinates up here and type in negative 3 divided by 7, enter, it would tell me, yes, indeed, that's the number in which you get out 0. In fact, I'm glad I did that because they want me to write the horizontal intercept in the domain to 3 decimal places as needed. So it turns out to 3 decimal places, negative 3/7 is negative 0.429. So I'm going to write that down before I forget it. So x is negative 0.429 was the x value that gave me an output of 0. So where you see negative 3/7, all I'm really doing is saying, look, let me go back to my home screen, second quit. All negative 3/7 is, if you want it as a decimal, is simply to 3 decimal places. Since the 5 is 5 or bigger, then you round this 8 up to a 9. So negative 0.429. So let's start answering some of these. In interval notation, our domain was such that the furthest to the left that the graph goes is negative infinity, and the furthest to the right that it goes was negative 0.429. So the way that's going to look in interval notation is you write the smaller number first. Well, my graph goes to the left forever, remember, so it goes to negative infinity to the left, comma. The furthest to the right that it goes is negative 3/7, but they're wanting us to round that to 3 decimals, so there it is. Now, I'm going to put a bracket here because negative 3/7 actually is the number that actually is okay to plug in and get a valid output. In fact, that's the number you plug in to get 0. And now, because I rounded it, I have a small issue with that. But I'm going to put a bracket and say that's part of the domain. But negative infinity, you never reach negative infinity. So you always will see a parenthesis around infinity or negative infinity. The function doesn't actually take on the value of negative infinity. Negative infinity is not a real number. Anyway, if you go over here, then my domain is going to be left parenthesis and then negative, and then to get infinity on MathAS, just type in 2 O's. They have to be lowercase, they have to be O's, not zeros, comma, and then it's negative 0.429. And then I'm going to put bracket, which is a couple buttons to the right, a couple keys to the right of the P on the keypad. And that would be my domain. My horizontal intercept was negative 3/7, comma 0, but remember negative 3/7 to 3 decimals was negative 0.429. So written as an ordered pair, that is the answer we want you to write in MathAS. And with point notation, you always use parentheses, negative 0.429. This is not interval notation, this is point notation. Negative 0.429, comma 0. So you always use parentheses. The vertical intercept, well, look, the graph starts to the left of the y-axis and goes to the left forever. There's no chance it's ever going to actually cross the vertical axis, so it doesn't exist. And it looks like I forgot to change the wording on this, but I'm going to change this in a few seconds. So in the video, it doesn't reflect it, but on your problem, it should say, if the intercept does not exist, write DNE. And I still haven't tried it with a lowercase DNE to see if it works, but so I'm going to play along and use capital DNE to say that the vertical intercept does not exist. And the very first thing I'm going to do after this video is change the code so that it says if your intercept does not exist, write DNE.